Hi guys, so today we're going to start off with sig figs. We're going to get through sig figs, scientific notation, and percent error. That was it. So we're just going to go ahead and get started, jump right in with that. This is probably review for some of you. I'm hoping it is, especially sig figs. I know you guys did it in ninth grade. It's probably been a few years for most of you, so we're just going to run through the rules. So I'm going to go ahead and turn myself off here. All right, so the reason why you want to use significant digits, that has to do with the level of error in measurement. So we talked about, let me go back a little bit here. We talked about this last class, that you do have a little bit of wiggle room with your measurements. You can basically guesstimate the next number that would come after the definite number. So like this was 6.3 or 6.4. So you're allowed to say that that is 6.35. The same thing we talked about the scale as well. So if you look again at the scale value, it's 10.27. So when you're using sig figs with your calculations, if this value is as far out as you can measure, if you can only measure to the hundredth spot, then your answer can't be any more specific than that. So you can't only have measured it to the hundredths place and then give me an answer that goes all the way out to the thousandths or further, because you're assuming a measurement that isn't really there. So let's go back over to the sig figs. Okay, so that's why we use sig figs, because significant figures, just make sure that your answers aren't giving you any more precision than the actual numbers that you measured were in. So if you measure something to be 3.5 centimeters, you can't say that you added 3.5 and 3.6 and now you have something larger than that. So our rules that go along with this. So with sig figs, any zeros that are between non-zero numbers are significant. Okay, so this type of problem is kind of obvious here. So you have 5 sig figs. The reason for that is that these zeros are telling you something. Okay, so they're telling you that there's 3,000 here instead of just 32 or 302. The second rule is that any zeros appearing before non-zero digits, like these zeros here, are not significant. So what that means is that these are just placeholders, basically, that you could easily rewrite this into scientific notation. It could be 4.5 times 10 to the negative third, and that accounts for those zeros here. So these zeros in front of any non-zero digits are not significant because they're just placeholders. Rule 3, any zeros after non-zero numbers are significant. So if you have a decimal point here and you have some numbers here and then zeros afterwards, these zeros are significant because they're telling you that this was measured with accuracy out to this decimal place. Okay, so whatever, let's say that this is grams, we're talking 450 grams. Whatever balance or scale was used was saying that this was exactly 450.00 grams. We can't say with certainty what the values were after that, but you know that for sure it went out to 2 decimal places. So all of these are significant. All of these numbers matter because they were actually measured. And our last sig fig rule is that if you do not have a decimal point, any zeros after a non-zero number are also not significant. And the reason for that is if you do not have a decimal point here, you're saying that this number is basically just an estimation. So someone might ask you, how much money do you have in your bank account? And you're like, oh, I have $7,000. If that's what you say, you're just kind of estimating that, right? Like you don't know for sure, probably off the top of your head, how much you have in your bank account, but you probably have like a ballpark value. You might say, oh, I got about $300 in my bank account. You know that that's not actually true, like that's not the exact value, but you know it's about around there. So because of that, if you get a number like this and it does not have a decimal point, none of these zeros are significant because you know that they weren't actually measured. And again, this can be changed with scientific notation very easily. So this would be 7 times 10 to the third, and then these zeros, you just don't need them. So there are some rules for adding and subtracting and then multiplying and dividing sig figs. I do understand that you guys will use your calculators in here, but you do want to keep this in mind when you are writing down the answer. So if you're adding two numbers together, your answer needs to have the same number of, the same number of numbers, I guess. I'm trying to find a different way to say that, after the decimal point. Okay, so here, this 12.5, there is one number after the decimal point. And then this has three numbers after the decimal point. Well, the 12.5 was not measured with the same precision. There's no values here after the 5, so we don't know what that is. So you can't assume that in the answer. This cannot be 17.846 because you don't know what this was here behind this 5. We can't assume that that was measured and that it was 0. So you have to go with the least amount of numbers after the decimal point in whatever your numbers were you were working with, and that has to be the same in the answer. So there's 1 here, so you can have 1 down here. Multiplying and dividing is a little more cut and dry, so you're just looking at the least amount of sig figs overall. So if you're multiplying these two values, this one has 5 significant digits. This one only has 1 significant digit because all of these are zeros in front of a non-zero number. So your answer can only have 1 significant digit. Scientific notation, on the other hand, is pretty important, and we will use scientific notation a lot on a regular basis. And I'll tell you right now, sig figs are honestly just not the most important thing. You'll use them in some career fields, but not all. Myself and some other teachers have talked to professionals out in the community, and most do not use sig figs. They don't go back in, and they're not specific about that. So if you're going into chemical engineering, something with precision that you need precise values for, you'll want to know sig figs, and it is part of our curriculum, so that's why we're going over it. But I am not going to be super strict with sig figs, just to be completely honest, because it's not going to change anything for us in this class. It's not going to change any of your outcomes. And most career fields you're going to go into, the sig figs are just not going to be that important. So they will be in some, so it just kind of depends on what you want to go into. So you'll see sig figs again probably someday if you're going into certain things. But scientific notation, we will use this a lot. So we'll use this on a regular basis. So you do need to know how to do this, be comfortable with it, converting things and taking them out of scientific notation with ease. So the general format here is over here on the side. So the m value, your factor, and then you have times 10 to your exponent, okay? So the number in front, that's what I'm going to call it, the number in front of your times 10, has to be a number between 1 and 10 with a decimal point, and then you can have things after the decimal point, like here with this number over here, the 4.5. So you had 450,000, and we moved the decimal point 1, 2, 3, 4, 5 places to the left. So that decimal point falls right between the 4 and the 5. So there's one number in front of your decimal point, and then we did 0.5 because that was what came after it, times 10 to the 5th. So whenever you are moving your decimal point to the left, or you're starting with a number that's larger than 1, your exponent will be positive. And then the opposite is true for smaller numbers. So if you're moving your decimal point to the right, or you have a number that is less than 1, your exponent will be negative. Okay, so all this exponent is telling you is how many places you moved your decimal point. So here we have this very small number. We want the decimal to fall right between the first and second values, okay, because we can only have one number in front of our decimal point. So we moved our decimal point to the right 9 places. So that's how we got here. We got 1.236 times 10 to the negative 9th. So with adding and subtracting without a calculator, because I know you guys will use calculators, but you might come across this sometimes where you don't want to use your calculator to add it. You just want to be faster than that. Adding and subtracting, the exponents have to be the same first, and that's easy to fix. So all you have to do is move your decimal points around. So you can assume here, like, the decimal point would fall here between after a 3. If you want this to match this exponent, right? So this is a 3 and that's a 2. We know that if we move the decimal point to the left, we're going to add 1 to our exponent. So if I move my decimal point, I'm going to change it over here. If I move my decimal point from here to here, that changes my exponent to a 3. Okay, do you see the difference between these two sides? So this one, the decimal point would have been here. It's kind of, that's an unspoken place for it. And we moved it one spot to the left, we added 1 to the exponent, and it changed it to this. Okay, so then you can very easily add the 2. You've got 5.3 times 10 to the third. Same would go for subtracting. So if you're adding or subtracting by hand, make sure that you're changing that. If you're doing it by calculator, you do not need to change anything. So here are some examples. Okay, so if we're adding and subtracting without a calculator, here you have the same exponents, so you just have to add what's in the front and then bring down what's in the back. So if you had 2.5 plus 4.2, you'd end up with 6.7 times 10 to the fourth. Okay, so since these are the same, you just bring them down. You don't have to change anything. On this side, these exponents are not the same. Okay, so we're going to have to do some changing. So the easiest way to do that is to move your exponent to the left 2 spots. Okay, so if I did that, I would end up with 0.042 times 10 to the fourth. Okay, no, this is not correct form for scientific notation. Okay, you're actually taking it out of the correct form in order to change the exponent to what you need. So we've done that. I'm just gonna cross this out so you know that that's not what we're working with. So we still have 2.5 times 10 to the fourth, and we're adding it to 0.042 times 10 to the fourth. So when you come down here, you're just adding all that together. 2 times 10 to the fourth. Okay, so that's the difference there. You're just moving your decimal spot back and forth to adjust your exponent. So if this was, if you wanted to move it the other direction, you could move it to the right, and then you could subtract from that. Oops. And the last little bit we have to cover here is multiplication and division without a calculator. So this is pretty simple. This is less complicated than the adding and subtracting, honestly. So with multiplying, you want both of your m values, the numbers in front, that you're going to multiply those as you normally would, and then your exponents you'll just add together. Okay, so you'll multiply whatever values are in the front, and you'll add the exponents on the back side. Division is the opposite way. So with division, you would divide them as you normally would, and then you subtract your exponents. So some examples of that. Get in here. So we have 3.0 times 10 to the fifth, and then 2.0 times 10 to the second. So if I'm multiplying these, you just multiply them in the front like you normally would. So I'd have 6.0 times 10, and then I'm adding my exponents. So this would be to the seventh. Okay. Same thing over here with division. So you divide as you normally would in the front. Okay. So you have 3.0 divided by 2. So you'd have 1.5 times 10, and you're subtracting your exponents. So you have 5 and 2. So it'd be 5 minus 2 give you 3. Okay. And that is it for today. So you can also find the slides on Canvas if you'd like to go back through this. The written out examples will not be there because I'm obviously doing these live with you. So if you have any questions at all, please let me know, and you can check Canvas for your assignment. See you guys later. Have a good day. Bye.